This video is to help you guys check your answer for the right side of your 10.3.2 notes. We are trying to find how many points of intersection there are between these two parabolas. Okay, and I can tell they're a parabola because they both have an x squared and an x, and that's what tells me it's a quadratic equation. Okay, step number 1 for finding the points of intersection are to set the equations equal to each other. Okay, so that looks like this. X squared minus 4x plus 5 equals negative x squared plus 4x minus 1. Now, I notice right away that this equation has an x squared and an x. It's quadratic, and the first rule of solving any quadratic equation is it must equal 0. So I can choose 0 to be on either side. It doesn't matter. So let's just say I want 0 to be on this side. That means I need to add x squared, so these cancel. I need to take away 4x, so these cancel. And I need to add 1, so these cancel. So now I have 2x squared minus 8x plus 6. And the third step is solve for x. So because it's a quadratic equation, I can do 3 things. I can factor and solve, I can use the quadratic formula, or I can complete the square. And my choice is going to be factoring. Why not? Okay, so factoring would look like this. So I need two numbers that add to negative 8x and multiply to 12x squared, because the product of the diagonals has to be equal. Okay, so if I'm adding to be a negative and multiplying to be a positive, negative times negative is a positive. And the factors of 12, 1 and 12, 2 and 6, 3 and 4. And if they both have to be negative to make a positive number when they multiply, negative 2x and negative 6x. So I'm going to go over here and add those in and then fill out my square. So let's see. I'll do 2x here, which means this is 1x, which means negative 6 and negative 1. So I know that they originally equal 0, so I can do x minus 1 times 2x minus 6 equals 0, which means x equals 1. This one's a little harder to see, so I'm actually going to set up my equation. I'm trying to find the x that makes 0. So plus 6, and then divide by 2. So one of my x values is 1. One of my x values is 3. Those aren't the points of intersection. Those are the x values of the points of intersection. To find the y pair that goes with it, I need to plug both x values back in to find the y pair. Okay, and it doesn't matter which original equation I choose. So if I go back up to the top, let's choose the first equation. Okay, so wherever I see an x, right here and right here, I'm going to plug in 1. And then another point, I have to plug in 3. So if I go down here, plugging in 1, y equals 1 squared minus 4 times 1 plus 5. And you can use a calculator or you can do mental math. 1 squared is 1, 4 times 1 is 4, plus 5. 1 minus 4 is negative 3, plus 5 is 2. So that means that one of my points of intersection is 1, 2. All right, I could do the other equation or I could do the same parabola. So let's just do the same parabola. I'll do the first equation. So instead of 1, now I'm going to plug in 3 for my x value. So it's 3 squared minus 4 times 3 plus 5. So y equals 9 minus 12 plus 5. Well, 9 minus 12 is negative 3 plus 5 is 2. So then my second point of intersection is 3, 2. And just to make sure my brain understands this, I'm going to label these as the points of intersection.